is it true that achieving absolute zero temperature is impossible? And is there an upper limit on how hot an object can get? So, what is the upper limit of temperature? Is the question, right? So, first of all, the lowest temperature you can have is called absolute zero. Absolute zero is about minus 273 degrees Celsius, which is 0 Kelvin. Hmm? So, absolute zero is 0 Kelvin on the Kelvin scale, which is minus 273 point something degrees Celsius. And Fahrenheit, it's something else. So, that is what absolute zero is. And that is the theoretical lowest temperature that you can have. So theoretically, the lowest temperature can be minus 273 point something Celsius, which is 0 Kelvin. It's not 0 degrees Kelvin, it's 0 Kelvin. So at this temperature, absolute zero, the motion of all particles in a substance will cease, which means that the substance will have zero kinetic energy. Of course, there is something called 0 point energy, which I will not go into. It's a quantum mechanical thing. But overall, all energy, all motion of molecules, vibration, whatever rotations, etc., everything will cease. So the substance will have zero kinetic energy. Now, is this possible? In reality, in reality, the it is not possible to achieve absolute zero. And this is because of the third law of thermodynamics, which states that the temperature, as the temperature of a system approaches absolute zero, its entropy, or the measure of the disorder on the system, will approach a minimum value. Okay. And this law also implies that it's impossible to reach absolute zero in a finite number of steps. So you can reach absolute zero, but it will take you an infinite number of steps to get there. So that's why it's practically not possible. So in practice, if you have a system, let's say you have a box and you're refrigerating it, you're taking as much heat out as possible. So the system inside the box gets colder and colder. Okay. Now, as the system gets colder, it's going to get more and more difficult. It's going to get increasingly difficult to remove whatever heat is left, because there's already very little heat left, and you're going to have to do tremendous amount of work to extract that heat out and take it out. Okay. So there are various methods that are used for cooling. Uh, Refrigeration has your standard methods, then there is laser cooling and whatnot. So these methods can bring your substance or your thing, whatever it is, your gas or liquid or whatever it is, to very close to absolute zero. But you can never reach exactly absolute zero because of these limitations, thermodynamic constraints, quantum mechanical limitations, and all that. So achieving absolute zero is practically impossible. It's not going to happen. You will not be able to achieve absolute zero. Now, what's the upper limit on temperature? Is there an upper limit on how hot an object can get? Well, theoretically, unlike absolute zero, there is no known upper limit. No, there's no known fundamental upper limit to temperature. So you can make something as hot as you possibly can, eh, using practical means. So there is no fundamental upper theoretical limit on temperature. Uh, there is something called a Planck temperature. Okay, so the Planck temperature is approximately what, 10 raised to 32 Kelvin. 10 raised to, and when it comes to the highest temperatures we have achieved on Earth, I think when it comes to colliders like the Large Hadron Collider or whatever, you may have a temperature of maybe on the of the order of a billion Kelvin, 10 raised to 9 Kelvin. But the Planck temperature is roughly about 10 raised to 32 Kelvin. So that is a difference of a factor of 10 raised to 23, which is ridiculous, enormous. So the Planck temperature so that is derived from various fundamental physical constants. It represents the scale. The Planck temperature represents the scale at which the effects of quantum gravity are expected to become significant. Uh, and At the Planck temperature or above the Planck temperature, the current physical theories will break down. I mean, we don't have, uh, we believe it is the current physical theories like general relativity, quantum mechanics, or whatever else, they are insufficient to describe the behavior of matter and energy at the Planck temperature or above the Planck temperature. So we don't know how matter, energy, etc., will behave at that scale and above that scale. So it's not a limit, but it's where our understanding of physics breaks down. Okay, so that's what it is. So there is no established theoretical fundamental upper limit on the temperature that you can achieve, but the Planck temperature is a theoretical boundary beyond which our understanding of physics breaks down. It no longer applies. So that's what it is. So absolute zero, achieving absolute zero is impossible from a practical perspective. Achieving as hot a temperature as you can is not impossible theoretically or practically, but our understanding of physics breaks down at and beyond the Planck temperature. And obviously, when it comes to a practical perspective, the highest temperature we can achieve is of the order of 10 of a billion Kelvin, 10 raised to 9 Kelvin, which is way, 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 way below the Planck temperature. It's puny compared to the Planck temperature. So, yeah, that's the answer.